Alternating current. You see, you start studying electricity with the chapter electrostatics, and gradually you come across current. Current that's known as conduction current. Conduction current is also of two types. One is AC, the other is DC. Now, almost in every field, AC is dominating, and this has become indispensable. There are certain specific areas, hardly 4 or 5, in which DC is required. Otherwise, every field is being dominated by AC. What is AC? The direction goes on changing regularly. That's a basic criteria. AC is that current in which the direction regularly changes. See, you need not say that value is also variable. Value is bound to vary if you say some current is getting from +3 to -3, because you are saying the direction will change. The direction changes, it means the value is also changing. So, alternating current, we just rotate a coil and current is produced. That current is given by the relation. Corresponding voltage is given by the relation. You see, this omega t term is known as phase. This is oscillatory in nature. You might say it is sinusoidal in nature simply because it could be represented by the sine function. So, it's also known as sinusoidal in nature. Here we are using sine theta. This omega t is called phase. Phase will give you the direction and the value of the current at a particular time. In these relations, I naught and V naught are the maximum value that we call peak value. If there is some difference in phase, it could be written as this. You see, sine omega t plus phi. When you say it's plus phi, simply means it is leading, its phase is greater than the phase of the current. And this could be written as minus phi. Not only here with the voltage, you could write with current also, but you'll have to remember plus phi simply refers to leading and minus phi refers to lagging. Now, since the nature of the current is of regular variability, it's regularly changing, obviously we'll have to go for the average value. If we consider average value in one complete cycle, whatever is the plus value, same is the minus value also. Obviously, the average value is going to be 0 for complete cycle. So, what we do, we prefer only half of the cycle and try to find out the average. If we find the average of sine square theta and then we take the root, that is the only option with that, because if we consider the average value of sine theta, it's going to be 0 for the whole cycle. So, average value we find for voltage, this thing. This is the average value where V0 is voltage amplitude, or you might say it is the peak value of voltage. Likewise, current will also have the average value. This comes out to be about 63.6% of the peak value. If you try to find out this 2 upon pi, you are going to get 0.636. But this is only for half of the portion. You will consider the average value only for half, either it is positive or it is negative. Then we have another option, because this method is not very convenient and suitable. We try to find out the root mean square value. You see, you'll have to focus on this nomenclature RMS square, go from right square, take mean and then take root. See, V square, then take mean and then take square. This is called root mean square value, and it's going to be You see, by squaring this relation, we could derive the result. That won't be very logical here to go into detail. You could square V0 square sin square omega t, and you must be knowing that sin square theta has the average value 1 by 2 for the complete cycle. By taking the square root, you are going to find this thing. Similarly, IRMS, this is also going to be, this is 0.707 times, that is 70.7% of the peak value. Now, what is the use of this RMS value? Actually, whatever the reference is made regarding AC, we always talk in terms of RMS value, whether it is voltage or current. We always talk in terms of RMS value. Suppose somebody says that we are having a supply of 220 volt AC. Then it is automatically understood that he is talking about the RMS value of that AC. One more thing, you see, there is one convention we speak, alternating voltage. It's quite good. But if somebody says AC voltage is getting supplied over here, we are having AC voltage, actually he is committing a mistake. It's not proper to say AC voltage, it is alternating voltage. But that is in practice, remember. This is in practice, people normally refer to this term AC voltage. Likewise, in the same flow, somebody says AC current is here, that's absolutely wrong. That becomes a joke type thing. You can't repeat same term two times. You see, AC itself is enough. Now, when you were talking regarding AC, you were talking in terms of RMS value. There is 220 volt AC. There is 220 volt DC. This is DC. When you are talking about 220 volt AC, it is RMS value, then peak value is going to be 220 root 2 by using the relation Vrms equal to V0 by root 2. This is going to be almost 311 volt. So, if human body gets shocked because of 220 volt DC, it is going to be the shock of pure 220 volt only. But if it is AC, he will be getting shock of this 311 volt. That means it's more dangerous. Obviously, when AC and DC both are compared, AC is going to be more dangerous than same voltage DC. One more thing, one must be alert. When direct current flows through a cable or conductor, it is going to be distributed throughout the cross section. Not only this, the current density is same throughout for every part of the cross section when it is DC. But when it is AC, there goes one very important law with AC, that's known as skin effect. What is skin effect? AC always flows through exterior of the conductor, means it is always confined. Most of the AC is confined to the external part only. So, why are we studying this? Because we are always concerned with the safety measures. If somebody gets shocked because of AC, the whole body behaves as a conductor. It's not good conductor, but it is conductor and it allows the current to pass through. And if it is AC, it will pass mostly through exterior part, and your heart and other interior material will be intact, safe. So, AC is not that much dangerous as DC, because it will pass through skin only through outer part. One more thing, high frequency AC is more likely to have a skin effect. Their skin effect is more dominating. That means a skin effect, when it is considered, high frequency AC is going to be more safe compared to low frequency AC.